Good evening and welcome to the launch of our first Electron mission for the new year. It is coming up to midnight here in New Zealand, where we are getting ready to fly the Cosmos Will See You Now mission for European space technology company Open Cosmos. Now, liftoff tonight is scheduled for 11:52 p.m. local time from Pad A at Launch Complex 1 or 10:52 a.m. GMT for the Open Cosmos team based across Europe. Now, my name is Muriel Baker, and it is great to be back with another countdown to launch for Electron and our first flight for 2026. And on board Electron today are two small sats by Open Cosmos that are heading to a 1,050-kilometre low Earth orbit at an 89-degree inclination. Now, the pair will verify new capabilities that Open Cosmos is developing, and it is the first time flying on Electron for the Open Cosmos team. So what a great way to start off the year by welcoming a new customer and launching a mission tailored just for them to this higher orbit. Let's learn more about the Open Cosmos mission.
People don't realize how much people use space data on a daily basis. And to some extent it's something good because it means that space data is already embedded on the daily life of all of us.
Open Cosmos designs, manufacture and operates satellites that help solve the world's biggest challenges.
If we don't understand where we are today, we cannot improve it. So one of the things that this type of data enables is to understand Earth.
And that's ultimately the goal, right? That this information is just helping humanity across the world continuously.
It's amazing what can be done with satellite data, whether it is extracting from imagery or extracting from sensors on the ground, which data gets collected by satellites. You can monitor climate, you can better understand the use of energy, sustainable use of natural resources. All of these are challenges that can be addressed thanks to this information.
The way we deliver this, we help achieve this data in orbit is through three main products. One is Open Orbit,
where we literally take care of the entire mission on behalf of the customer.
Is to design the satellite from scratch, manufacture it, test it, launch it, and even operating it.
And the customer just gets the service that they need, whether it is for navigation purposes, telecommunication, or Earth observation.
And that's what has brought us to the point where we are one of the leading companies in this field. We are delivering missions as a service to both institutional and commercial customers.
The second product is called the Open Constellation. And that's a constellation where we mutualize satellites from different partners. So rather than having to pay for a huge constellation, each one of them, they can share the data
between ourselves and others to lower the cost.
It provides multi-sensor variety of data that then can be used to derive insights and information on the ground.
And the third product is Data Cosmos. And Data Cosmos is basically a platform where we gather, harmonize diverse types of data sets. We enable the analysis of those datasets with third-party analytical tools from some of our brilliant partners in AI and so on around the globe.
By having this data enables people, companies, and organizations and be able to take action. So that's why it's called actionable intelligence, because it's intelligence, information that then you can take action on.
Uniting dedicated satellite missions, Open Constellation shared infrastructure, Data Cosmos insights, and secure connectivity, we build satellites to understand and connect the world.
We're thrilled to be providing Open Cosmos with a ride to space today. And tonight's mission might be our 80th launch overall for Electron, but it is great to be getting started with a busy year of launches in 2026. Now, launch operations have been going smoothly so far today, and the weather is expected to remain clear all the way through to T0. Electron's looking good, and our operators are ready to make their way through the final few milestones in the countdown to liftoff. In fact, as we approach T-minus 12 minutes on the clock, we are coming up on the Go, No-Go poll run by this mission's launch director, Michael Pearson from Mission Control. Now, this is the final assessment on whether all of Electron's systems are go for launch and that our operators are happy to proceed. And we have operators stationed at the Mission Control Center you see on your screen and at our Range Control Center located at the launch site. So let's listen in to both and check in on how we are tracking for launch.
All stations LD on mission, proceeding with the go, no-go sequence. Stage.
Stage is go.
Avionics.
Avionics is go.
GNC.
GNC is go.
VCon.
Pecan is go.
T1.
T1 is go.
GC.
GC is go.
PLS.
PLS is go.
RSO.
RSO is go.
MET.
MET is go.
MM.
is go.
And LD sup.
LD sup is go.
Okay, the go, no-go sequence is complete. We are T-minus 11 minutes, 20 seconds, and counting. We are go for terminal count auto sequence at T-minus 10 minutes. From this time, the 3-word procedure is in effect.
There you have it. That is confirmation from Mission Control that all systems are healthy, and we will be proceeding with the remainder of the count. So that T0 liftoff time remains 11:52 p.m. New Zealand local time, or 10:52 a.m. GMT. And we have a 2-hour launch window for today's mission, so if we need to stand down for any reason, we have a few backup opportunities over the next few days as well. Now, today's mission is headed on a southern trajectory from Mahia along the coast of New Zealand before it heads over Antarctica and on its way to orbit for Open Cosmos. And if you're new to Rocket Lab launches, let's introduce you to our Electron rocket launching today's mission. So standing there on the pad at 18 meters tall, Electron is our carbon composite rocket powered by 3D printed rocket engines. Now the rocket comes in 2 stages, along with a kick stage platform at the top of the launch vehicle that is attached to the pair of Open Cosmos satellites for this mission. There they are, they're nestled inside the fairing, and the next thing they see will be their new home in space. Now, where you see a white band across the rocket below the fairing is where liquid oxygen is being loaded into Electron's second stage. The low temperature of that propellant is freezing moisture on the outside of the rocket. And you can see the same effect to Electron's first stage further down as LOX continues to flow there as well. Now, Electron's total vehicle mass with that full load of propellant is 13,000 kilograms at liftoff. At the bottom of that first stage are 9 Rutherford engines, each of them 3D printed and powered by batteries. Now, with individual capability of up to 5,600 pounds of thrust force at sea level, combined, the 9 engines produce about 50,400 pounds of thrust force at liftoff. And we use a single space-optimized Rutherford engine for the second stage, and on the kick stage is another of our 3D printed rocket engines called the Curie. We use this propulsion system on the kick stage for orbit raising and lowering maneuvers, and to circularize the kick stage for payload deployment once we reach the mission's 1,050 kilometer target altitude.
Checks complete.
Copy that.
S-band is switched to high power for flight.
Stage LD mission.
LD stage.
Proceed with sequence 60 stage terminal checks.
Copy, stage terminal checks in work.
Stage 1 and Stage 2 high voltage batteries ready for flight.
Now, like I said earlier in the show, tonight's launch is our 80th mission, and it is coming hot off the back of one of our busiest years ever since Rocket Lab was founded almost 20 years ago. Now, we launched more times than we have ever done before in a single year, with 21 launches across launch complexes 1 and 2, both here in New Zealand and on the east coast of Virginia. We also opened Launch Complex 3 there as well for our new bigger rocket Neutron. And 2026 is set to be another massive one in spacecraft missions built by Rocket Lab, with our largest production contract secured just before Christmas with the Space Development Agency, as well as a couple of Launch Plus spacecraft missions flying on Electron set for 2026 too. Now, while the countdown continues, here is a quick look back at what we got up to last year to set the scene for the new year ahead.
2, 1.
Who's ready to do it all over again this year, hey? We are looking forward to breaking even more Rocket Lab records in 2026. Now, back to the countdown, and like I said earlier in the show, tonight's launch is our 80th mission, and we have just 4 minutes or so left to go until liftoff. So what will happen next is that we will turn to the launch auto sequence that comes in at around T-minus 2 minutes. That's when Electron's flight computer takes over autonomously and runs through those final milestones all the way through to liftoff. Then at around 1.5 minutes into the launch sequence, we will start to hear some of those final calls as we get close to final pressurization of those tanks as well. And then it's up to the mission control director to then announce the T-minus 10 seconds countdown to liftoff and then launch for open cosmos to space. So with 3 minutes 50 seconds left on the clock to get us there, let's hand it over to mission control and listen in to those final counts.
All stations LD on mission. From now, there should be no red flags on your critical LCCs. VCON LD mission.
LD VCON.
Please lock auto sequence and confirm.
Confirmed.
Confirm all flight computer ASGOs are green.
Confirmed.
Okay, all stations, we are go for auto sequence start at T-minus 2 minutes. LD is go for launch.
The vehicle is fully on internal power. ITS is green and enabled for flight.
Box load complete. System is in recirculation. Anti-geysering is disabled.
Stage 1 and 2 tanks are pressed for flight.
High flow engine purge enabled.
T-minus 20 seconds and counting. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Liftoff.
Stage 1 propulsion is nominal.
Electron has left the pad and is off to meet the cosmos on this launch from Launch Complex 1. And as velocity increases, we are coming up quickly on the moment of max Q, or maximum aerodynamic pressure against the rocket as it clears through Earth's atmosphere. We'll hear the call out from our GNC operator in mission control shortly that is monitoring Electron's guidance and positioning.
Approaching max Q. Cleared max Q.
And Electron has cleared max Q at T plus 1 minute and 20 seconds into the mission. The launch vehicle is now passing 18 kilometers in altitude as it reaches speeds of over 2,500 kilometers an hour. And up next will be 3 events across Electron that will all happen within seconds of each other. First up will be MECO, which stands for Main Engine Cutoff. That's just as it sounds. That is when the 9 Rutherford engines at the bottom of Electron's first stage throttle down and then shut off completely ahead of stage separation. Then the second stage will separate from stage 1, and 3 seconds later, its vacuum Rutherford engine ignites to carry on with the mission. You'll be able to see those 3 events happen in real time from Electron's cameras, and those call-outs should be coming from mission control shortly too.
15 seconds to
burnout
staging.
detect mode.
MECO confirmed.
Stage separation confirmed.
Stage 2 ignition confirmed.
Stage 2 guidance is nominal.
That is MECO. Stage separation and second stage ignition all successfully cleared for Electron as we continue on to orbit. The vehicle is moving now at more than 8,000 kilometers an hour at more than 100 kilometers above Earth on our way to that 1,050 kilometer target orbit. Now, there should be no blockers for the next milestone, and that will be fairing jettison, when Electron's nose cone splits and separates to expose those open cosmos payloads to space. And there it goes.
Fairing jettison
That is
confirmed.
Electron's fairing separated and fallen away as planned. And there on your screen are the Open Cosmos satellites integrated to our kick stage and attached to Electron's second stage as it powers past 8,600 kilometers an hour now. Our next milestone will be battery hot swap for that vacuum Rutherford engine there, scheduled to take place at around 6.5 minutes into flight. Four minutes and 9 seconds into the mission now. There's Electron from our ground tracking camera, and we're also hearing nominal calls from our operators in mission control, which shows that all remains healthy with those Open Cosmos satellites on board Electron. Now, a couple more minutes to go until we reach battery hot swap on that second stage. And what that involves is that the Rutherford engine that uses its electric motors and high voltage batteries to feed propellant into its combustion chamber, those batteries are ejected because the longer session of the second stage's journey means that the batteries it started with run out before we reach the end. So we swap to a new set that will keep that engine running. All right, we are coming up on battery hot swap soon for that second stage engine. And when that switch out occurs, what you will see is the silver packs on your screen right now. They'll be jettisoned from the vehicle. And that's both our visual confirmation that the hot swap occurred, and we should also hear that call out from mission control at about the same time, which is around 6.5 minutes into the mission.
Guidance nominal, 200 seconds remaining. HVB discharge holding nominal, approaching hot swap in roughly 30 seconds. Throttling down.
Battery jettison confirmed.
Nicely done. That is battery hot swap successful for Electron's second stage Rutherford engine, with no change to the vehicle's trajectory as that second stage clocks more than 16,000 kilometers an hour, now more than 280 kilometers above Earth. And next up will be SECO, or second engine cutoff, which is the moment that that engine will shut down to separate the kick stage into its nominal transfer orbit. Now, to reach the 1,050 kilometer orbit required for this mission, the kick stage is released at the mission's perigee, or the closest point to Earth in its trajectory, and then sent on an elliptical path to meet its apogee, the farthest point. Stage 2 vacuum nozzle is still glowing bright at 7.5 minutes into the Stage 2 burn and 7.5 minutes into the mission overall. So have a look at the dials on your right-hand side of your screen there. You will see the percentage of the propellant that is remaining in the Stage 2, and we'll be taking these tanks all the way to empty during this burn. That's what will get us closer to that perigee before we can coast around the other side of Earth in preparation for payload deployment. At around 9 minutes into flight is when the engine shutdown for Electron's second stage is expected to take place, just before the kick stage with the Open Cosmos satellites are released to begin that elliptical journey. Now just a few more seconds to go until that happens with the Rutherford, otherwise continuing to burn bright on your screen for its 6.5-minute duration. Now the next call we should hear from Mission Control is that guidance is terminal for the second stage before engine shutdown. Let's listen in.
Seco confirmed.
Stage separation confirmed.
There we go. That was SECO confirmed across the nets and by what you saw on your screen there with that engine nozzle cooling down. Now that cutoff has occurred. And the kick stage is in its nominal transfer orbit as it heads toward that altitude target for this mission. Now that coast around the Earth will take around 55 minutes or so before the Curie engine on the kick stage lights up to course correct the orbit to a circular low Earth orbit. And we're going to take a break from the webcast while that happens, but we'll be back to follow along with the kick stage engine cutoff and payload separation at around T+1 hour 7 minutes. We'll see you back here soon.